Today we're going to study scale drawings and models. Our goal is to apply and extend previous understandings of ratios to scale drawings. In this lesson, you will apply scale models to real-world situations. Let's review. We remember that a proportion is an equation that relates two equal ratios. For example, the proportion 7/10 and 35/50 are proportional because when reduced, they give us the same ratio or same fraction in this case. In this case, we have a scale of 5. We can solve a proportion by finding the cross products. In other words, we can see that 7/9 is proportional to 21 over a number. Well, when we multiply our cross products, we get 7 times x, or 7x, equals 9 times 21, or 189. Then we can ask ourselves, 7 times what is 189? Or we can divide both sides by 7 using our good old-fashioned friend algebra to isolate 1x is 27. So that's how we can solve a proportion by finding cross products. If you're still struggling with that, go to previous tutorials and see the many other ways that we can solve proportions. A common mistake is that students will write proportions incorrectly. In this example, the ratio of girls to boys at a middle school is 7:8. There are 248 boys at the school. How many girls are at the school? A common mistake is students will write 7 to 8 is 248 to what? Well, in this case, we need to remember that we have girls first represents our 7, and boys represents our 8. So if we know that there's 248 boys, they need to be across from one another. So it should read 7 is to 8 as girls, so I might even just use a G instead of X, is to 248, which means that I would have, of course, 217 girls, not boys. So always make sure that you are looking at your adjectives. That'll always help you. So, what is a scale? Well, a scale demonstrates how the dimensions and actual dimensions are related. A scale drawing is a diagram of an object which the dimensions are in proportional to the actual dimensions of an object. You don't need to write down the example, but maps and floor plans are examples of scale drawings. An architect will draw a blueprint, which is a scale of the building he or she is going to create. When we read a map, we see that it is proportional. 1 inch might equal 500 miles, for example, to the actual location we are visiting. Go ahead and take a minute to make sure that you have your vocabulary written down in your notes. Let's look at an example. A floor plan uses a scale of 1 inch equals 12 feet. How many feet are represented by 8 inches on the floor plan? Again, we need to first always look at our nouns. What two things are we comparing? 1 inch equals 12 feet. So I have my first proportion. 1 inch equals 12 feet. And I'm going to rewrite inches over feet. Why did I do that? That's going to help me remember what should be in my numerator and what should be in my denominator consistently. So I have 1 inch is 12 feet for my first proportion. I need to know how many feet are represented by 8 inches on the floor plan. A common mistake is students will write x over 8 because they see, oh, feet, inches. So they automatically, of course, don't think about their nouns. They just see, oh, okay, this is my x, this is my 8, and they write it in order, literal order. That's not how it works. what I need to do is say, I have my inches, which is 8. Inches needs to line up with inches. Inches to inches, feet to feet. So I might even use an F for my variable. I chose an F because that's, again, going to help me with my cross products. So now I can use cross products. I have 1 times F, or 1F, which is F, equals 12 times 8. And again, I go up and down with my cross products, just like the lazy way. 12 times 8 is 96. So, in the actual floor plan, I have 96 feet. Another thing that you should really just kind of remember is ask yourself at the beginning of the problem, which one's bigger, the model or the actual item? And it should make sense. If it's a map, of course, the real place is going to be bigger. So your number should be bigger than your represented inches or feet or whatever it is. And if you're doing a scale model of a ladybug, most likely your scale model is going to be bigger. So just think about what makes sense. That's also going to help you say, well, does my answer make sense? 96 feet is represented by 8 inches on this floor plan, for example. That would make sense because, of course, 8 inches is my model. That's small. 96 feet, that's much larger. That's my actual floor plan. So there's some quick tips. Let's look at another example. A museum is creating a full-size Tyrannosaurus Rex from a model. The model is 2.5 feet in length from nose to tail. The resulting dinosaur will be 40 feet in length. What is the model's scale? So in this case, we're looking for the scale. So I need to know, okay, is my scale going to be larger or smaller than the actual dinosaur? Well, in this case, we know that the model is 2.5 feet. The resulting dinosaur is 40 feet in length. So I know that my scale of my model is smaller. So that's a good question to just ask yourself right off the bat. So in this case, we need to write a ratio. Then we need to simplify. So I just might have model over Tyrannosaurus. So my model is 2.5 feet in length from nose to tail. The resulting dinosaur will be 40 feet in length. So what I need to see is, what's my ratio? Well, remember that a ratio can be simplified. When you have a decimal on your numerator, that makes it a little bit more challenging. What we need to say is, well, I know how to say 2.5 divided by 40, which is another word for a ratio, is a division problem. And I actually might write it as a fraction divided by 40, because when I do it that way, I get 5/2 times the reciprocal of 40, 1 over 40. And then, of course, that gives me 1/16 is my scale. And it is important that you write your ratio as a scale. If you did it the other way, you would have had a decimal that you needed to convert into a ratio. So my scale model is 1:16 for the scale. And that makes sense. 1/16 of the actual dinosaur size. And then, of course, you can use scale models to think of other things. I wonder what the scale of Layla to this Tyrannosaurus Rex would be. And this is a life-size model, by the way. Now it's your turn. I want you to carefully complete the guided practice. Let's look at the first example. The scale on a map is 1 inch to 25 miles. Find the actual distance in miles for 3 inches on the map. Remember to carefully think through those nouns. What two things am I comparing, and which should be bigger, the map or the actual distance? All questions you should be asking yourself. Let's look at another example. A scale used to build a model of the Wright Flyer, in other words, the Wright brothers airplane, is 1 to 72. Find the wingspan of the model airplane if the actual Wright Flyer's wingspan is 12 3/10 meters. So you are going to have some decimals to deal with, and with this problem, cross products is going to be your best friend. And again, ask yourself the question, which one's going to be bigger, the actual airplane or the model? Go ahead and take a minute to pause this tutorial and solve your guided practice now. In this lesson, you have learned how to use your knowledge of ratios and proportions to scale models and drawings. With these scales, you can apply them to architecture, to models, art, nature. Think of all the endless possibilities that you can use in order to compare numbers and proportions. Remember to use cross multiplication as a method for solving such problems. Before you learned how to solve proportions, now you will use proportions to solve problems involving scale drawings and models. Another great job today, and keep up the good work!